based on the data, based on the in the a priori knowledge, first level information, a first level grouping we can do. This type of grouping, first level grouping can be done just based on the forest non-forest area segregation. Then within the forest, what is the dense forest, what is the low open forest, this type of first level of grouping can do. And then based on these grouping, sample points can be distributed. This is what this example is, the growing stock estimations, not only growing stock, all estimations they are doing also like this. Stratifications, these are mostly these are mostly by physiographic zones. There are 16 physiographic zones segregated, and within the 16 physiographic zones, estimations are done based on sampling design, specific sampling design, what they are following. Here, one example is that if we use satellite data, what type of satellite data we should use? Here, satellite data is there. Here is that if we see this is our 5.1 meter resolution. Earlier we used to use for 5.1 meter resolution. This is one for reserve forest of our Meghalaya, where this center is, my center is located. Here, if you see, this looks like this forest is these are of course this black tones are forest area. It looks like almost monotonous, but if you have the technology, if you have many, if you have the technology, if you can process it, if we use little bit higher resolution satellite data, you see the within the for the same area segregations are possible. Now here, if you see here, if you distribute the sample points, you will distribute say maybe one here, one here, one here. What will happen? It will have underrepresented. But now, if you have a segregation, then you will be able to judiciously distribute the sample points so that the sample points locates all type of forest areas. Here another example of, see, this also looks like monotonous. When earlier sample, forest density was mapping within 5.8 meters, it was little bit arbitrary type. But same area, when we do classification again with 1 meter high resolution data, these are more prominent, more clear, and segregations are better, and more number of classes are coming up. And if you see, if you remember forest cover areas of FSI earlier, once there is a difference between 95 and 98, I think, number of total area has been decreased. This is because of changes in resolution. So that's how the resolution is a very important type of what type of work you are doing. Based on that, resolution is important. And now when like this, when you do the visual interpretation, first you need to understand, you need to go to the field, you need to tally with the imagery and the ground, and you need to generate some keys. An example of ground density is corresponding to the cutoff set image and the ground. Like this, we need to go to the field, take imagery, and generate the key, so that when 5 people are doing the interpretation at the same time, of course, if it is visual interpretation, 5 people are doing the interpretation, their individual perception will not work. If once you have the standard key, like generate a standard key like this, so that when all these areas join together, then you will have a seamless density map of the particular area. This is very important. Here, one example of this one Kukurkata Reserve Forest, that is some part of Assam. Like this, forest density map is prepared. Then this is one example of along forest division. This is what forest density map by 1:50,000 scale, this by FSI, and this is what this prepared by at NISAC 1:10,000 scale. Instance, you may not, these differences may not look like, may not be there, but if you see in a little bit minutely, you see that within these classes there is a small variations are there. If we analyze a small area, you see this. Now you see FSI and that prepared by 10,000 scale by NISAC. A trend may be similar, but within this classes there are lots of variation. This is because since it is digital, it is purely based on spectral signature. However, here this is mostly based on texture, tone, and association, because this is visual. Then if you see the statistics, only differences are there. In total forest cover will be almost same, but however there could be some differences within the different forest classes, open, dense, and very dense. This is nothing but there is no changes actually on the forest, but this is only due to different formats of image interpretation, digital as well as visual. So like this, based on your requirement, study area, we need to opt for the type of interpretation, type of process, type of techniques what we are going to use. Now, if I say smart this is FSI is wrong, no, it is not wrong, because it is not possible to do entire country's image interpretation within 6 months, 7 months time through visual image interpretation. It's not possible. So there has to be some regional level, or there has to be some standard methodology for regional level, which is digitally done by FSI. Then that is what this density map is, one of the type, one of the input for the stratification. Then forest type. I'm not talking about how classification is done, but I just like to highlight here is that if you see this image, now you know all the red patches are the vegetation. But within the red, there are lots of differences. If you see this here, this area, these are red, very dark red. These are also dark, very dark red, blackish red. However, there is a red. But if you see the granules, there's a differences. Now, if you know the ground, and if you know the signature pattern of different types, forest type, forest species composition, you will know that these are look like smooth. So this normally grass or this type of vegetation give, if it is a healthy, of course, it will give this type of reflectance, young plants. However, since if you see the almost uniform type, that means these are almost at the same height. So these are what type of plant? If you go in one of the places, you will know these are nothing but a bamboo. So that means that's how you can classify this. You can classify, and now based on signatures of those particular sites, which is also called as a training site, you can run the classification. Whatever classification technique you follow is up to you, but you can generate a very good forest type map of these areas. Again, another important here, if you see only one image, it's fine. But there are some areas where same area. This if you see the left image, it looks like all are open soil. However, in the same image in November, it looks like very dense. That means these are deciduous forests. That means you need to judiciously use the satellite data technology available to identify all the possible and correct way of classifying the forest. Another small techniques what we can use very easily. Suppose we have two dates of data, one is February, one is November. Same satellite data, if you see, same area, if you see in the two seasons, these are different directly in FCC looks like different. What we can run, we can run NDVI. NDVI already explained by how NDVI is run, what is the range, what that type of outputs can come, already explained by Professor and Dr. Singh yesterday. So this is what the NDVI image is up to that. Now if we combine, suppose we combine this NDVI image of 1st November of 2013, or that is band 1, that is in the red I have given. Suppose NDVI of 5th November in green band we have given, and NIR of 1st November, and the satellite data if I put, image will look like this. Then another, if we change the band combination, first NDVI of 1st November 2013, and then a band 2 of this one NDVI of this 5th November February you have given same NDVI, only that we have changed the NIR band here. See that the image differences. Now this type of combination, if you run together and then run a classification, we can simply at the same single image we can classify all entire area into different segregations. Of course, some fine tuning is required. So these are some of the techniques. That is up to you what type technique you will use, but whatever technique you use, we need to go to the ground, do some ground validation first, do the accuracy estimation as Professor Singh, Professor Joshi has explained accuracy. Those things we have to do and generate the final map. This is one example of Meghalaya forest type map of Meghalaya. This is what we have generated. So the different forest types we have generated, including all other classes, other land use classes. Like this you can generate, but important point is here we have 1, 2, 3, 4, 5, 6, 7, including bamboo. There is 7 classes. So 7 classes here in a forest type. Suppose I use the forest density, there are four density, so 7 and then 7 and 4. If we put 4 from 7 from forest type and 4 from the density, if we use, number of strata will increase by 4 into 7 equal to 28. 28 classes we will get. If we use again the elevation one of the classes, suppose 3 classes, then 28 into 3, that means that many strata will come. So that may not be possible to handle, and we need some minimum sampling points from each sampling representation from each strata. So that many sampling doing, and again will be a huge Herculean task. So we need to reduce this even forest type. So you can regroup again some forest types into some of the common features like deciduous, semi-evergreen, or pine, mixed bamboo. These are based on your knowledge of the region. So you can again regroup some of the classes together to reduce the one of the strata or some of the strata. So here what happened when we group into only four type of forest types, and 4 into 4 from density, only we are getting 16 classes. And 16 into 3, if we use from this elevation, then the total strata will come down to 48. So like this, we can judiciously use the data what you have with you. In addition to that forest density, forest type, there are many other classes, many other type of information which you can derive from satellite data or geospatial technology. You can use for your stratifications. Like one is the example. See, if you see this one, this is from Lantingmupa Reserve Forest of Assam, Dimahasa districts of Assam. See, if you see here, this is the reserve forest boundaries. Yellow boundaries are nothing but the compartment boundaries. If you see, if we treat this compartment and this compartment in the same way, it will not work because of slope, because of aspect. Plants growing this region and plants growing this region will not be the same, or will not be at the same field condition, vegetal conditions. So we need to consider those areas, those points also. So like this is one from riverian forest from Mizoram Kolasip division. There, what is important is that they are 200 meters from the both sides of the river is that they defined as the riverine reserve forest. If you see this image, this is the list tree, and this is a panchromatic image. This looks like almost similar. However, if you say in data, if you see in the 3D, you will get the segregation, and you will feel the all other factors what you should use. So that means DM is very important. If you have DM, you should use it. So now I'm coming back to some of the examples from the actual work, from the case studies. Here is one example from Alam Forest Division. Here there's a forest type. We have regrouped the entire Alam Division into only 3 classes. The 3 forest type, that means forest type is 3. And then as per FSI, this is 3 classes, 10 to 40, 40 to 70, above 73 classes is regrouped. So here we will get this 3 into 9 strata. Then we have slope maps. Then we have again slope is very important because also requirement is that forest departments now requirement is that they need to understand, they need to estimate the growing stock available below 30-degree slope and above 30-degree slope, because nowadays they need to conserve this whatever trees growing, those areas growing within the. So what I was telling that so that 30-degree, above 30-degree, this you can also generate once you have the data with you, digital data with you. So this DM slope map you can generate from DM. Then this is one example of Arunachal Pradesh, Meghalaya, Mizoram. Also, all data are available with us. Also, it's available for you too through our web portals. So like this, DM is available. Once you have the DM, you can wander the way you like. You can generate the strata, generate the different classes. Here it is elevations. Once you have then elevations is very important, for the growing conditions of trees and for the species distribution. Like elevation, these are the different type of strata you can use. Then once you have elevation and then you have DM, slope can be generated. Now here, like this, for along divisions, when we combine all this data, here we have utilized forest type, density, and elevation. There's three. So there are three. It will be total 3 into 3, 9 into 3, total 29 strata we have got here for the along division. So once you have the strata and then you have the digital data with you, you know the total area available within each strata. So now these are different strata. These are total area is 3,16,603 hectare area total for along division. So each and every pixel, every area of the division is now mapped. Once you have the data,